In question 7, the complex numbers u and w are u minus 1 plus 7i and w is 3 plus 4i. In part 1, we have to show that the complex numbers u minus 2w and u upon w in the form x plus iota y. So in the first step, u minus 2w, that will become minus 1 plus 7 iota minus 2 times 3 plus 4 iota. Simplifying this, we'll get minus 1 minus 6, which will become minus 7, and plus 7 minus 8, that will become minus iota. So this is u minus w. For u upon w, we'll write first minus 1 plus 7 iota divided by 3 plus 4 iota. Now, as we have to remove the denominator, we can take the conjugate and multiply and divide with the numerator and the denominator. So this will become 3 minus 4 iota divided by 3 plus 4 iota. Simplifying the numerator, we'll get minus 1 times 3, that will be minus 3 plus 4 iota. 7 times 3 is 21, so that will become plus 21 iota. And 7 times 4 is 28, and iota square is minus 1. So that will become minus, and this will be a minus 28. Divided by, in the numerator, we'll have 3 times 3, and this is 3 minus 4 iota, not plus iota. So this will become 3 minus 4 iota. So we'll apply the identity, which is a plus b into a minus b is a squared minus b squared. So we'll get 9 minus, so 4 times 4 is 16, and iota times iota is minus 1. So this will become minus 16. So simplifying this, we'll get minus 3 plus 28, which is 25. 4 iota plus 21 is 25 iota, and this is dividing by 9 plus 16, which is 25. Simplifying this, we'll get 25 plus 25 divided by 25, which will become 1 plus iota. So this will be u upon w. In part 2, we have to prove that angle AOB is equals to 1 upon 4 pi, where O is the origin, A is represented by U, and B is represented by W. Now, to understand this, first we'll try and sketch this on an Argand diagram. So this is the origin. U has the coordinates minus 1 plus 7 iota, so we can put it over here. And this is U. And W has the coordinates 3 plus 4 iota, so this will be somewhere over here. And as it is talking about the angle AOB, so we know that U is A, W is B. So let's say this is point A, this is point B. We have to find this, we have to show that this angle is 1 upon 4 pi. Now, to find this angle, what we'll have to do is we'll have to find the complete argument of the complex number U and then subtract it from the argument of the complex number B. So we can first write it as that angle AOB will be equals to the argument of U minus the argument of W, which can be written as argument of U upon W. Now, as we already have U upon W in a simplified form, which we did in the first step, which becomes 1 plus iota. So finding the argument of U upon W, we'll do argument and we do tan inverse of, so we do tan inverse of Y upon X. So the y coordinate of u upon w is 1 and the x coordinate is also 1. So this will become, so the argument will be tan inverse of 1 upon 1, which is equals to pi upon 4. In part 3, we have to state fully the geometrical relation between the line segments OB and CA. Now we know that O is the origin, so OB will be, and as the coordinates for B were, so B was 3 plus 4 iota. So OB will become 3 plus 4 iota. And finding CA, so CA will be equals to A minus C. A was presented by U, which was minus 1 plus 7 iota. So we'll write minus 1 plus 7 iota over here. And C is represented by U minus 2W, which is minus 7 minus iota. So in this question, C was represented by U minus 2W, which is minus 7 minus iota. So we'll write minus 7 minus iota over here. Simplifying this, we'll get minus 1 plus 7 iota plus 7 plus iota. Simplifying this, we'll get minus 1 plus 7, which is 6. 7 iota plus iota is 8 iota. Now, once we have both OB and CA, we can see that they are in a particular ratio. So if we take 2 common from CA, we'll get 2 into 3 plus 4 iota, which means the first thing we can say is that OB and CA, they are parallel. And for the second mark, we'll have to give the ratio. So the ratio for OB is to CA will be 1:2. Or we can also write it as CA is basically twice of OB. Both answers will be marked correct.